So the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank XLR for being a part of it.
I was very much interested in learning digital marketing course for a very long period of time, but I don't get a proper platform. So later for my college, I get to know about XLR and I enrolled in XLR course. It was really good experience. Our course has been taken by Mayur sir, and he was very good teacher. He not only focusing on theory part, he is doing how real digital marketing works, and it was in total very good experience. I get so much of knowledge. Here they not only focusing on study, they are also conducting different exam to test our knowledge, and as we are giving the exam, so to appreciate our work, they give certificates for the toppers, and along with the certificate they give hampers. Thank you, XLR.
Recently, I was searching for digital marketing courses online in Google, and I came across XLR, and I attended a digital marketing course which was for 15 days. My mentor Mayur helped me for attending these classes. So he is a very informative and helpful guy. In the course end, there is a exam which I topped, so I came to the XLR office in Bengaluru. This digital marketing course has helped my career and my skills to develop, and the certificate has helped my company to join. Thank you, XLR.
I came to know about this course from my college. Actually, for learning platform, this is very nice, and I learned from here ChatGPT and AI from online. Vikas is teaching for me for AI generative and ChatGPT. We are using this technology in more. And after finishing the courses, I came from for collecting the certificate. I seen the classrooms and faculties. Classroom is very nice. After the completion of exam, they will give gift and certificates. Thank you, XLR, for giving these courses. I learned a lot from this. I gained the more knowledge from here, and thank you for XLR for teaching us.
Hello guys, I'm Vikram Mahajan and I'm studying in Swami Vivekananda Institute of Technology College, and I came across a training program which was mobile app development using Flutter, which was given to us by XLR Solutions. I came across this program through my college faculty, who told us about this program, that it is a very good course and you should enroll in this course. So I enrolled in this course, and initially I felt really good about this course because they started everything from a very basic point of view, that even if someone who doesn't know anything about Flutter or anything about mobile app development can also learn the same way the ones who know about it are learning. So no student was left behind and everyone was given equal attention. All the doubts throughout the course were cleared. And if we had any questions also, we were like, the trainer was also ready to stay for a longer time than it was scheduled, even for the sake of doubts. So that shows how important the students are to them. So it was a really good experience with XLR's program, and by the end of the training program, I was able to develop my own application. And through the development also, there was another point. So our sir taught us about how we can connect our own mobile phone to our laptop and write code in our laptop, and you can see the output in your phone. It was really creative and interesting for me. I felt really good about that. So in the end, I developed my own mobile application. I showed it to my mother. I showed it to my friends. I felt really good about it. So I would really suggest XLR. I would recommend it to all my friends to take courses from here, as they focus on the children, focus on the students, and they focus on what's necessary. That is, the students' doubts gets cleared and everything else. So today I came down to the XLR office to collect my certificate. So I got to know about what other courses XLR is offering. It included data analysis, data analyst, social media marketing, and full stack Java, and many more courses which were interesting, and they gave us an insight of how everything happens, and they take you through the course from the starting of the course to the end, and what next, that is placements as well. How you should be going into the interviews and how you should be approaching to companies, your resume building, and there were so many things which XLR is going to help you in, and they are ready to give you all the knowledge required even if you are a beginner. So I really felt good about this visit, and I would really recommend XLR to everyone who's listening to this, and also to all my friends, that I had a very good experience with XLR, and I would suggest you to experience the same. Thank you.
Hello everyone, my name is Satish and I am from Swami Vivekananda Institute of Technology. I am here to share my experience about XLR program. I took part in the XLR program that was conducted in the last month about the mobile app development using Flutter. What I liked the most about this session was the trainer started from the scratch. That means even the beginner who don't know about the basics of the program, even they can learn the most from this program. It gave me hands-on experience by developing a project which was the final outcome. Thank you XLR for giving me this opportunity, and I would also recommend all my friends to take part in the XLR programs. Thank you.
Good evening, everyone. Please confirm me if my voice is audible in the chat box. Right, thank you. Okay, right then. So, welcome to this student development program on Internet of Things, and for the day 4. So, we started it from Monday, and so we discussed few basic concepts, or like the fundamental concepts of this particular Internet of Things, and we learned few things like architecture and what are the applications of that, characteristics, advantages, disadvantages, and what are the business opportunities, career opportunities of IoT. These are the few things which we discussed in the last few sessions. And today we'll try to discuss few more concepts. And I hope by today we'll complete the theoretical part, and in next sessions we'll try to see some hardware sessions, like hands-on sessions, like how to collect the data, how to push the data to the cloud, and that things we try to cover it from tomorrow. Okay, and today we'll try to discuss a few concepts, like right, fine. Coming back to our lectures. So in the last, from the beginning, we try to discuss about this IoT, which is nothing but Internet of Things. Things are nothing but the devices, etc., etc. Like things, any might be the things, living thing or a non-living thing or devices, etc., etc. Right. So, what is internet then? So, today's topic is like, what is internet? We'll try to learn about this particular internet. Okay. Can anyone tell me what is internet is all about? Okay. In daily, we are using this particular internet, right? Right. Can anyone tell me what is this internet is about? What is internet? Yeah. Can you can reply in the chat box, guys? To connect the world and update the new technologies, interconnection between the computer devices. Yeah, okay. Find any other answers? Integration of technologies. Okay, right. Something which helps us to ace all world at a tip. Okay. Provide previous full form. Okay, fine. Right. Any other answers? So, you know better than me. Connection of networks. Yes. Yes. Right. Fine. A signal, it is a source to find anything. Yes, almost all your answers are correct. Okay, so let me dive into this. Coming to this particular internet, we call this, it serves as an um, WAN, which is nothing but while wide area network, and it uses something like protocol like is called TCP/IP. Okay, things must support this particular TCP/IP in this particular things, where whatever the devices which we are using the in our technology IoT, that particular devices should support this TCP/IP protocols. Like, so right, so it is nothing but it is nothing. It is internet is nothing but about like but interconnected computer network. Okay. For a practical deployment, we need a gateway, which often needed a network. Am I right? So this gateway offers that relaying the packets between the network and the internet. Okay. So in general, there as having a 5 layer model will be there. So every device in this particular IoT must follow this particular protocol to communicate with each other. Right. So we need to check whether that particular device will have that particular ability to transfer the data using this particular internet or not. Okay, so that is an overview of internet. Let's dive into this. Okay, so uh, this internet is generally it is defined as an information superhighway to access the information over the web. Okay, and it is a nothing but how it is defined as in many ways, but I defined it like an internet is a worldwide global system of interconnected computer networks, and this uses a standard internet protocol, which is nothing TCP/IP protocol. Okay, so the internet is a worldwide interconnected network of hundreds of thousands of computers of various types that belong to multiple networks. So this is a general definition of this internet. Okay, so let us see how this particular internet is impacting in our day-to-day life. We can't imagine our day without internet. So we see. I don't want to explain more because even we are connecting to this particular meeting through internet only, right? So let us see how this internet is impacting our day-to-day life. In that, first of all, let me discuss with communication. So communication is like an instant messaging and email. So platforms like WhatsApp, Messenger, email, so which allows us that um, communicate instant communication with anyone globally. Okay, like social media things are like Insta, Facebook, Twitter. Okay, these are the sites are there which enable the people to connect with each other, share some knowledge, or interact with a broader audience, or some other ways are there which we can connect with our friends. Okay, and also we can have that video calls also. Previously, if you, I don't know whether you remember it or not. So if you want to do a video call, or if you want to connect to US or UK, which are who are staying in abroad, it is highly difficult for us to communicate. But whenever internet is coming, we are not even talking, but we are directly doing some video calls, like in services like Zoom. There's one which platform which we are using now, Skype, FaceTime, which facilitates this face-to-face communications regardless of the distance. Okay, and also it works good in working and business. Okay, right. So there is a remote works are there. The internet will make that remote work and telecommunication, communicating people, things are possible, which allowing the people to work from anywhere. So that's what in the COVID time we worked, like few employees are working like work from home. Okay, using internet. Without, if internet is not there, it is highly difficult for anyone to work, right? And there are like e-commerce sites are there, like online shopping platforms, which you know, like Amazon, eBay, Alibaba, like Flipkart, etc., etc., which are having a revolutionary, because and here right now Zepto is there, Blinkit, or Big Basket. So even if you see that, even the Zepto people are giving that jewelry also within 10 minutes of time. Okay, right. So previously, if you want to buy something, you need to go and that. But here, because of this particular e-commerce, it is very easy for, we are sitting at home and we can purchase all this. But then how these things are happening? It is all due to that particular internet. And also digital marketing. Okay, the marketing strategies got more interest. We can target any number of people using this particular one. Previously we used to market using some pamphlets or using some posters, okay, some banners, etc., etc. Now we have a digital marketing things are there. Even in our XLR also we have that particular digital marketing courses are also available. All these are happening using this particular uh, internet only. And coming to this education field, that's what we are working, right? Online training is there, like you are going training through online only, am I right? So right, right, there are some platforms are there, like courses, Khan Academy, Coursera, Udemy, NPTEL, so which are offering these courses virtually on any subject. Okay, which we can access from anywhere, right? So there are some research is also going on, access to the wealth of information, like through like digital libraries, academic journals, like I said, there are some educational websites are there, which are we can support that learning and research on it. So virtual classrooms are also available, like like Zoom, Microsoft Teams, the Google, what we say, classrooms, which enable us to interact or collaborate this learning experience. Just we can sit at home and we can experience that particular virtual classrooms. Am I right? So there are some other things are there, like entertainment. We all know about it. Streaming services will be there. Netflix, Spotify, YouTube, like Hotstar, Geo Hotstar. So we can access to the movies, music, videos, everything, right? So online gaming are there, right? PUBG, multiplayer gamings worldwide. You can connect to any type number of gamers worldwide in real time, right? There are social media platforms are also there. We can use it, can generate content, trends, viral videos. You can also see YouTube, that same link is uploading in the YouTube. You can access that anytime, am I right? So there are some information access, news and updates will be there. So search engines are there, health information can be done. So there are some daily activities, bankings, navigations, smart home devices are there, right? So and also um, we have this social impact things are global connectivity. activism and advocacy and community building. So there are some challenges and considerations are also there. So we have some issues will be there. That is also one point. So privacy concerns are there, cyber securities, digital divide. So even though even our government is also awareing us about this particular cyber security. Am I right? So these are all are happening only because of this particular internet. Okay, so just me, let me show you uh, what we say a time spent with this particular media using this particular internet. You can see this is the stacks little bit older, but you can see there are like people are spending almost like 6 hours 35 minutes on that particular uh, for music streaming services like the podcast radio. They are spending 3 hours. Like these are the some stacks are there. And also I'll show you one more stacks. Okay, of course that is also a little old, but you can imagine. So this is what the data, okay, for which is generating using this particular internet in this particular world, and this data is for only for 1 minute of a day. In a minute of a day, this much data is generating. You can imagine. Okay, you can imagine, right? Just have a look about it. So YouTube having a new data is uploading like for every what we say 72 hours once the data is generating. Sorry, 72 hours of new data is generating. There are almost 40 lakhs of searches are happening in Google, Tinder, Facebook. You can even, this is only for 1 minute. And this is also little old data. Now you can, all these particular, what we say, numbers are increased right now. Okay, so that is how much. So all these data is storing in the cloud platform. That is only by using what we say internet. Okay, so this is about that. So let us go and dive into this particular history of that. Okay, so these are the origins, right? It was developed by Apparet, so which is developed in the late 1960s by the U.S. Department of Defense and Research Development. Later, we have some expansion to universities and research institutions. So we have after that they developed it in a full fledged, like they introduced this particular TCP/IP things. Creation of email systems are there. Yahoo came on into the picture at that particular time. Skype is there. So there are like invention of World Wide Web will be there, WW. So by Tim and Lee, though there is web browsers are also there, Mosaic and Netspace. After that, we have the commercializations coming to the picture. Growth of this internet service providers. .com came into the picture. Okay, these are some history. And now, right now, we are in this particular era, the rise of social media, mobile internet, cloud computing, and also we should not neglect our technology, which is nothing but Internet of Things. Using this particular internet, we are going to uh, work on this particular technology, right? So let us go and dive into these things. So first of all, we need to know about this internet protocol. So what is internet protocol? Can anyone tell me in the chat box? Is my voice audible, guys? I just received a message like my voice is not audible. Is it audible? Can someone reply to me? Yeah, thank you. Thank you so much. Right. Can anyone tell me what is this internet protocol? All right. A set of rules to define the use of internet. Yes, fine, fine. Set of instructions, set of rules. Yes, yes. Right. So you are right. Everyone are right. So let us discuss about this. These IP protocols or right, internet protocols are a set of rules that govern how a data is need to be transmitted across the networks. So these protocols are essential for enabling the communication between the devices on the internet or any other networks. So both the sender and the receiver should follow the same protocols in order to communicate the data, in order to understand it better. So let's take an example of a language. So any language has its own set of vocabulary, am I right, and a grammar. So which we need to know if we want to communicate in that particular language. Am I right? Similarly, over the internet, whenever we access a website or an exchange of some data with another device, then these processes are governed by some set of rules, and that set of rules we'll call it as an internet protocols. Okay, so let us see how these are working. um, the internet or and many other data networks work by organizing the data into small pieces, which we call it as a packets. So each large data which will be sent between the two network devices is divided into some small packets by the underlying hardware and the software. And this particular each network protocol defines the rules for how its data packets must be organized in a specific way according to the protocols of that network supports. So overall, what I mean to say is the data will be um, splitted into small pieces called packets, and these packets will be in an sent to the over a network to the receiver in an organized manner. There will be some protocols are there. Using that particular protocols, we are going to send that particular data, right? So why we need these particular protocols? So it may be that the sender or a receiver of data are parts of from different networks located at different parts of the world, which are having at a different data transfer rates. So we need protocols to manage this flow of control of data, and also to access the control of this particular link which are being shared in the communication channel. Suppose there is a sender, one sender is there, say suppose some X, who has a data transmission rate of 10 Mbps, and there is a receiver of Y who has a data receiving rate of 5 Mbps. Since this particular rate of receiving the data is slow, so some data will be lost during the transmission. So in order to avoid this, so receiver Y needs to inform the sender X about the speed mismatch so that the sender X can adjust his transmission rates. So similarly, the access control decides the node which will access the link shared between in the communication channel at a particular instant in time. So if not, the transmitted data will collide if many computers send data simultaneously through the same link, so which results in the loss of that particular data. So that is the need of this particular protocols. So let us see about this particular addressing. Right. So, let us discuss about this particular IP address. Okay. So this IP address, say suppose if you go for any what we say device, if any device got connected to internet, an address will be generated. So suppose if we are what we say, yeah, our house is there. Whenever our house is we built an any house, what happens, the government will give some identification, am I right? So what are these identification? Nothing but our house number, am I right? So here this house number is a unique address, am I right? So similarly, if any internet is connected to any device, this particular address will be generated. So an IP address is nothing but it is an internet protocol address. Okay. So which is nothing but a unique address will be given to identify the device over the particular network. So it is almost like a set of rules governing the structure of that particular data sent over the network or through a local network. So an IP address which helps that particular internet to distinguish between the different routers, computers, and the websites. Okay. So it also serves a specific machine identifier in a specific networks, and helps to improve the visual communication between the source and the destination. So this is what the IP addressing means. So do you have any doubts till now? If not, we'll try to shift to some details of this particular IP address. Right? Someone is asked like about the dark web. Okay, whatever the it might be, they need to follow the same internet infrastructure or then IP rules. They need to follow to work on that. Right. Fine. Then we'll go to the next one, which is nothing but the types of internet protocols. So these are the different types of internet protocols are there. Okay. Out of which TCP/IP is a basic fundamental protocol. Uh, right. For all this internet, you can see. I hope you all know about this particular uh, I mean, you know, few of these particular protocols. Am I right? So maybe you studied in somewhere. So these are the different protocols which are available in that. So right now, what we say, this IP, in IoT, we are generally till now we not till now from the beginning we are using IPv4 addresses. So for that now we are shifting to IPv6. Okay, because of that some complexity, some security purpose, we are shifting that. Okay. Someone is asking it out. So, like, it suppose if someone knows your IP address, they can hack your devices using some. There will be some tools are there. So, using that particular tools, they will identify. I mean, they'll know whether your ports are open or not. If your ports are open without any security things, okay, definitely they'll come into and what we say hack your things. So that's why everyone say there is like HTTP, HTTPS. So yes is nothing but that more secured things. Okay, so even whenever you are think, these search engines will warn you this is not a prescribed one. Okay, because there is some things are there. Okay, so nothing but if your ports are open, it is easy for anyone to hack your devices using that particular IP address. Okay, fine. So that's why many people like use VPNs. Okay, VPNs are nothing but they'll try to change their IP addresses. Whenever they do this hackers, they try to change their IP address or not to get caught. Okay, so right now we are not going in deep about that. Fine. So let us discuss the basic fundamental protocol. So let us see one more thing. These are the network protocols which are there. Generally, mainly used network protocols. Okay, so how the data, some may get some data will be transferred in a secured manner. Okay, some will transfer in a just a normal fashion. We don't care about that particular acknowledgement. Okay, whether his connection is established or not. Some will work like they'll work on like establishing the connections. Like that, there are the different protocols. Okay. Sir, I'll discuss the basic fundamental one, which is nothing but the TCP/IP protocol. I hope few of you know about this particular TCP/IP protocols. Okay, so I don't want to go in deep and discuss about this, but I'll just give an overall gist about this particular TCP/IP things. Okay, right. So this TCP/IP model is a fundamental framework of commuting computer networks. Okay, it stands for the transmission control protocol or internet protocol. So which are the core protocols of internet. Okay, so this model will defines how the data is transmitted over networks, which ensures some reliable communication between the devices. So basically, it contains four layers: link layer, internet layer, transport layer, and application layers. So each layer has some specific functions. So that helps to manage different aspects of network communications. So which makes it easy. It is essential for understanding and working with that different networks. Okay. So right? So what does this particular TCP IP will do is, the main work is like it is used to transfer the data for a computer from one device to the another device, and the main condition of this is to make data reliable and accurate, so that the receiver will receive the same information which will receive by the which is sent by the sender, and also it assures that each message reaches its final destination accurately. So this TCP IP model will divide that packet data into the packets and combines them at the other end, so which helps in maintaining that accuracy of the data, so while transferring from one end to the another end. Okay, so here are the differences between the TCP and an IP. Okay, so let us concentrate little bit on this. So the purpose of this particular TCP is nothing but which assures the reliable and ordered and error-checked delivery of the data between the applications. But IP Internet Protocol will takes care of this, providing these addresses and routing of packets across that networks. Okay, and this TCP is nothing but this is a connection oriented, and IP is nothing but the connectionless. So the function of this particular TCP is which manages the data transmission between the devices, which ensures the data integrity and order. And for the IP address, it manages or it routes the packets of data from the source to the destination and based on that particular IP addresses. So error handling can be done in TCP and no error handling can be done in IP address. There will be a flow controller will be and congestion control will be there in TCP, but not in IP address. So data segmentation is also happening in TCP, which breaks data into small packets and then reassembles them at the destination. But in IP, it will breaks into packets, but it doesn't handle about that reassembling part. Okay, so the header size will be large, which is of 20 to 60 bytes, but here in IP it is very small. So reliability is like provides reliable data transfer, and here in IP we doesn't guarantee about it. And here the transmission acknowledgement in TCP it will be there, but in IP we don't have this particular acknowledgement kind of things. So this is the basic differences. Let us work on this particular what we say layers of this particular TCP IP. Okay, so first of all, let us discuss about the application layer. So this is the layer which are comes across for the user, right? So this layer is a close to the users, which interacts directly with the software applications. Okay, right, which provides the communications between communication services will be there. Okay, right? So it handles a high level protocols, issues the representation, encoding, and dialog control. And there are some protocols will be used like HTTP, FTP, SMTP, DNS. These are the few protocols which we use in this particular application layer. Okay, and we have next layer is nothing but the transport layer. So this layer is responsible for end-to-end communications, error handling. So it assures the complete data transfer and controls the reliability of a given link through error connection and flow control. Okay, and here we also follow some common protocols, TCP and UDP. So TCP, right, that is what we are discussing. So this provides reliable, ordered, and error-checked delivery of a stream of data between applications. UDP is like the connectionless. TCP have some connections, but UDP doesn't have any connections. Okay, so even we are also following that same things like UDP protocols. Okay, okay, we'll discuss that UDP in the next slide. So I already included that in my lecture. Okay, and next we have an internet protocol. So this layer is responsible for addressing and the packing and routing functions. Okay, from IP addresses will be there. Using that particular IP address, the data will be transferred across the networks. Okay, so using that particular IP address only, the path will be defined. So for that, we have some protocols: IP protocol, internet protocol, internet control message protocol, address resolution protocols. So there are different things, protocols are there to communicate, to transfer the data. And the last one is like we have link layer, so which is also called as a network layer or network interface layer. So this is responsible for the physical transmission of the data over a network medium. Okay, like we might connect to internet, ethernet or a wi-fi for those, right? So this link layer will take that particular responsibility to work on that. Okay, so this is a overall discussion overview of all the layers which we discussed. So application layer, which is nothing but interface with the software applications. So there are some protocols are there: HTTP, HTTP, some protocols. Transport layer, which manages the end-to-end communications or header handling. Internet protocol, which handles the logic addressing, routing, and packaging. Link layer will manages the physical data over that network address. Okay, so this is how the data will be transferred or communicated. These things. Okay. So here, let me have a one question over here. So say suppose I sent a message. I message like, "How are you?" Okay. How this message will be transmitted through this particular protocol? Can anyone tell me? You can tell me in the chat box. What is it? Like say suppose question is, say suppose I sent a message like, "How are you?" Okay. How this message will be transmitted to the receiver? Okay, encrypted. First, the message will be divided into packets. Yes. Encoding, decoding packets through passing through that. Yes. Yep. So someone asked a question like, what is the difference between data address? Okay, you mean that IP address and data address? So I mean, I think that so IP address is nothing but it defines it identifies a device on a network, while data address is nothing but it identifies the location of that particular data in a system or in a network. Okay, okay, right, fine. So many of you gave some answers. Thank you so much for your response, guys. All right. So let us think. So to understand how a message like "How are you" is sent through this particular IP TCP IP protocol. So let us break down into this based on these particular layers which we discussed here. Right. So here, first of all, application layer will come into the picture. So the message "How are you" is generated by this particular application through some what we say applications like WhatsApp or a chat app or a web service on your device, whatever the things. So there are some protocols will be there. These protocols are used for these particular applications, and then the data will be pushed to the transport layer. Okay, so this layer we know, right? This reliable data transfer will be happening in this particular. So some TCP will be used over here. So TCP will establish a connection between this sender and the receiver. There are some handshake models are there using TCP, like sender request connections, synchronize what is acknowledgement. So acknowledgement will be there. So there the "How are you" message will be divided into smaller segments. Okay, and then there will be some port numbers will be there. So this TCP assigns that particular port address. Am I right? So like source address and the destination address, like 80, 443, 18, something. Some there are some port address will be there. So using that port address, the data will. I mean, they make some connections will be there. Then internet layer will be there, which will handle the addresses. Nothing but they'll took care of that particular addresses, the source IP address or the sender IP address. That IP address or IP header, we call it as, will be attached to that particular TCP segment. Okay, so that TCP segments will have that particular what we say source IP address or destination IP address. So and then packetization will be happen. So the TPC segment will have that particular IP packet, so which will be routed on that. So again, last thing, link layer will be there. So network layer or link layer, physical layers will come into the picture. MAC addresses will be there. So that can be done in this particular link layer. Again, coming to the receiver side, the same reverse order will be happened. Okay, that is how the data will be transmitted. So I hope you understood about this. Okay, right. So let us discuss about this UDP. Why? Because nowadays we are all using this particular UDP things. Okay, so that's why let us discuss about this particular UDP. Okay, so it is also a transport layer protocol. It is a part of this IP suite, which is nothing but UDP IP suite. But here this TCP UDP, it is not unreliable and connectionless protocol. But TCP is a reliable and connection. Okay, so there is no need of establishing a connection before transferring the data. So here the best example is the same one which we are using, Zoom. Okay, so I connected it, the people who are you are receiving it, but I don't know whether I'm keep on talking and keep on explaining you things, but I don't know whether the data is transferring or data is receiving to that particular sender. Sometimes you will send a message like your voice is not audible, your screen is not visible. So like some may say that your screen is visible for us, your voice is audible for us, but some may say that this is what the UDP is all about. So they doesn't have any connectionless. Okay, it is not reliable. So that is what this UDP is on. But right now, even PUBG also, like online things. So PUBG they play the games fastly, whether they don't know whether the data is sent or not. Say suppose in TCP, if you send a mail, so if the mail is not sent, you will get a acknowledgement that the message is not delivered. Like that, we have this particular UDP. Okay. So what is this particular UDP? It is one of the core protocol, just like a TCP protocol. Okay. Right. Communication protocols uses some internet for time sensitive transmissions such as video playback or DNS lookups. So unlike this TCP, this UDP is connectionless. We doesn't guarantee whether the data is delivered, ordered, or any error checks are there. So that's why many of the people will, I mean, some applications they mainly work on this particular UDP, like Wix, Hotstar. So we doesn't they try to just transmit the data. They don't know whether the receiver is receiving it or not. Okay, so this is about the UDP. TCP, we have this layers also, like application layer. So there are some other protocols are also used over here. Transport layer will be there. So here there are some key features will be there in this particular transport layer. That is what the UDP. Okay, there are some structure of UDP is also defined over here. So you can check it little later. So network layer will be there. Structure pattern what we discussed in that TCP, the same way, but little different things. Okay, so this is what request and response will be kick upon respond sending the data. Okay, so this is the difference between a UDP and a TCP. I'll also discuss about the differences between the TCP. You can see the TCP will be having acknowledgement in sync acknowledgement and acknowledgement will be happen in this particular, but UDP doesn't have that thing. So gaming, video streamings, online video chats. Okay, those are the examples of this particular UDP. But coming to the TCP, sending mails, transferring mails, web browsing, if you are requested, you will get that particular message. So here, once requested, that is enough. Once we connected, then continuously the data will be transferred. We don't care about that particular things. So let us see the differences between this TCP and UDP. Right, this is a type of services as we all discussed. TCP is a connection oriented, UDP is a datagram oriented protocol. Okay, so here the connection we try to make some connection, but here we don't have any connection things. So reliability will be there. For UDP, you don't have that reliability. So TCP is reliable as it guarantees the deliver of data to the destination router. The deliver of data to the destination can't be guaranteed in UDP. Okay. So error checking will be there. So it is extensive error checking mechanism will be there in this TCP. But UDP we have only the basic error checking will mechanism will be there using some checksums. So acknowledgement will be present in TCP, but we don't have any acknowledgement in UDP. So sequence of data is a feature of this particular transmission product control, but there is no sequence of data in UDP. Sequence or nothing but packets. Whenever they receive the packets, everything will be kept after the destination. The packets will be aligned. Okay, but in UDP we don't have that. So TCP is comparatively slower than UDP, but UDP is more faster, simpler, and more effective than TCP. Okay, so and the speed is slow, and coming to UDP the speed will be fast. So that's why many of the vendors are shifting from TCP to UDP. So reconnection of lost packets is possible in TCP but not in UDP. Okay, there is no need retransmission once your data is lost. Say suppose as we are listening, so if you have any internet issue, you don't have that particular retransmission of the data. Only if you have any break after that in the live streaming also, if you have any issues like in through internet or something, you will skip that particular part. Am I right? You can find this in live streamings in YouTube. Like header length will be there 2260. Here in UDP has a 8 bytes of fixed length header. So TCP is heavyweight, UDP is lightweight. So here there are using some handshakes in things, as this is connectionless. We don't have any handshakes for that. So TCP doesn't support broadcasting, but UDP supports this broadcastings. So the broadcasting things, all this comes under this particular UDP. Okay, like Geo Hotstar, what we say, Netflix, all these are like under that particular, no, not Netflix, like live streamings all comes under this particular. So here TCP uses some protocols and UDCP uses these types of other protocols. The connection stream byte type is a byte stream. So it is a message stream. So overhead is like low but higher than UDP. It is very so applications are nothing but this protocols is primarily utilized in situations where and when a safe and untrusty communications procedure is necessary, such as in email, web surfing, military services. But in UDP, so that is not a concern. Game streamings, video, music streamings, etc., etc. Even are also following the same thing. Okay, so right, so this is about that's TCP and UDP. If you have any queries, you can ask me, guys. All people are use the same things, guys. There is no other things. As I gave you some different types of things, it's not about based on the country. It's based on the what is a company. Okay, some company will use some protocols. Other companies will use some other protocols. Okay. So coming to some accurate, it depends upon there are applications. It's not about that. So if you need some acknowledgement, say suppose IoT need an acknowledgement. Okay, right. So whenever say suppose the temperature is more, if suppose sensor is giving more, we need to get a notification, right? So if you want to agriculture field, the data will be transferred to the farmer and the farmer need to then we need some acknowledgement. Should be an exchange of data, but UDP doesn't have that particular thing, so it all doesn't need about that particular what we say accuracy on that. Okay, so TCP is nothing but transmission control protocols. Okay, guys. Any other things, sir? If we are to make some college level position, which is so for a basic level, I recommend the TCP things. That's what I explaining, right? We need an acknowledgement, right? So for that, we need this particular what we say Acknowledgement. So we need that acknowledge. So we use definite TCP protocols. Okay. Any other queries, guys? Just give me a second. Okay, right. So let a small topic, which is nothing but the connected devices and smart devices. So, connected devices are nothing but these are the devices which are controlled by the user. And for example, washing machine, though it is a programmed one, so someone should initiate this, like smart TV and a smart AC. So AC, whatever things, so that should be controlled by a user. Okay. And then next one is a smart devices. So what is the difference between that this smart devices and the connected devices is smart devices should have some mechanisms, what we say, like a learning mechanism. So it should have that particular learning mechanism. So that devices, we call it as a smart devices. Okay. So whenever the search engines will be there, like our devices, Alexa, they'll so for the initial stage, it will try to learn from what are the users based on the voice. It try to learn. After that, if you ask that to play some songs, it will play from your favorite playlist. Okay, favorite songs. So that Alexa, we call that as a smart devices. Okay. So it need to learn by itself. Okay, it need to process. So that can be happen in this particular IoT devices. So that's why we call that as an smart devices. Okay. So connected devices are not IoT devices, but all IoT devices are connected devices. Okay. All right. So this is one small thing. Okay. So next we'll try to discuss about uh, one more topic. Okay. So just a second. Like now we'll try to discuss about embedded operating systems. Okay. So just I want to give a glance overview of these particular things. So as we are discuss, whenever we are discussing about this embedded structure of an embedded, so we have this particular operating systems that I told you that that is an optional, but let us discuss on these things. And the people will have more opportunities on this particular embedded domain, guys. So it is not constrained to only EC students. It is for everyone. So I hope there are some EC students are there. So people, if you are really interested, there are embedded Linux things are there. Embedded engineers will be there. So it is very useful. You can grow because all our devices, I told you, right? All our devices, almost 95%, which are there in our day, which we are using in our day-to-day life, all are embedded systems. Am I right? So there is a lot of scope for you to develop in this. Okay. So let us discuss about this um, on this particular embedded operating system. I just want to discuss on this. All right. So here, right. So suppose let me take one particular example. Like we all know that we all surrounded by machines and devices for our everyday tasks, right? So imagine what if any device okay, which are manufactured to perform a specific task. So it is doesn't work it in a normal fashion. If it does not serve the purpose, what it means, so it is a terrible failure, right? So these embedded systems, so will have that particular have an operating system perform that flawlessly as this. Okay, so as we all know, this embedded systems is a combination of an hardware and a software. So without this particular embedded system operating systems, it is hard for us to understand or to know what how this device is performing, how this defined device with is what we say perform, or how this device is functioning. Okay, so let us see what is an embedded operating system first. Okay, so this embedded operating system we generally call this as a specialized type of operating system, so which is used for non-computer devices. Okay, not for a computer, non-computer devices to execute a specific task seamlessly. Okay, so the core function of this particular embedded operating systems, so it lies in executing the necessary code. Okay, so which enable the device to perform its designated functions effectively. So besides that, so the primary use of this is to operate the machine effectively and reliably to manage the software and hardware resources. Okay, right. So this that is about this particular operating system. Uh, so here, what is an operating embedded operating system? It is nothing but a computer operating system designed for use of an embedded computer systems. Okay, it have some limited functions. So embedded itself is a used for only a specific task. So these operating systems are also having a limited. So it is also refers to like a real time operating system, nothing but RTOS. Okay, maybe you know about this RTOS. As I told you, this is the main goal is nothing but for a specified task for non-computing devices. Okay, so here this embedded operating systems will be developed on some software languages which we all know like C or C++, and its system will improve the overall efficiency by controlling all the hardware resources, minimizing the response time for specific tasks which devices are built up. Okay, so these are the key differences. I just want to give a differences between an embedded operating system and a normal desktop operating systems. Okay, so I'm not going in much deep and just giving an overview. So this particular embedded system was first released by this Apollo guidance computer system, and the first desktop thing was released in 1960. Okay, that is not NLC online system. Okay, and here it takes a minimum time, but this desktop operating systems will take some time when compared with embedded operating systems, because you all know, right? Whenever we open our mobile application, it will open in minimum, but it's not same as your system, computer system, right? So here the cost will be very low, but the desktop cost will be high. There is the embedded system will have any fewer applications, but the desktop have more applications. So it is executed only a single task, but this desktop computer will can execute multitask simultaneously. The boot time is fast when compared with a desktop computer. So this embedded operating systems require less storage, and desktop computer need more storage, and uses it embedded uses some only flash drives for storage, but here desktop will use both hard drives and flash drives. So here web browsers takes less to load the websites, but here in desktop it the web browser takes long to load the websites, less time to restart, long time to restart, easy to use and understand, but little bit complex to use and understand. So this is the basic differences between an embedded operating system and desktop operating. So let us discuss how does an embedded system will works. Okay. So right. So these particular embedded systems, okay, so is having a high demand. In the beginning also I told you, right, this is a high demand technology because we need a best product development. Am I right? So we need a best product, and this particular best product will have with a with unique features, and the technology or the system should work effectively. Am I right? So for that we need this embedded software developers will be there. So this technology is limited, but we have a large in scope with some superior functionalities for that end product. So the operating systems will have a limited scope, but has the capabilities to perform a better task, reliable enough to operate irrespective of the size, the process, or the power. Okay, it works well with others technologies also. Can update with this particular OS can be happened to any software with multiple features are also there. Okay, so moreover, these systems can manage bugs, security vulnerabilities, so which can operate with some flexible will taking out that particular bugs, etc., on time to time basis for the end users. So this is all the key features of why we need an embedded system, how this embedded system thinks our work. So this is a brief history. We already discussed that in the differences. It was discussed in invented in 1960s with some rocket machines. Okay, so let us discuss about the types of an embedded systems. Okay, so we all know, right, kernel is the heart of an any every embedded systems. Okay, so this kernel is an internal integral part of an operating systems, so which plays a crucial role in this hardware engineering process. So will this kernel will manage the system's hardware, memory, files, and essential resources. Okay, so there are multiple operating systems are there in this particular embedded systems. So let us give an brief idea of what are the different embedded systems are there here. So this kernel is a significant part of all these embedded sorry, operating systems. So it handles synchronizations, inter-task communications. It incorporates a range of features which allow the device to control or the functions in a real world. Okay, so these are the different types of embedded systems which are available. Okay, just I'll want to go through this each and every one in a quick manner. This is a real-time operating system. It is a deterministic operating systems with limited functionalities, which allow multi-threading applications by giving uh, these things. Okay, and multitasking operating systems. So it is an embedded system, okay, which performs multiple tasks simultaneously according to the application's needs. So it is like I say that specialized programmed to process between the various systems. Okay, and there are numerous functions will be there according to the need, according to the applications. Okay, so if multitasking is a part of any app development, then scheduling the algorithms are also useful, and that can quickly establish the rules for a better organizing the task. So multitasking operating systems will use include this particular scheduling algorithms, so simultaneously with some set of rules for multiple tasks. Okay, so primitive operating systems will be there. Okay, and single rate monotonic operating system, single system control loop, Linux operating systems, we all know, right? Even our embedded system like Raspberry Pi, BeagleBone, they use this particular Linux operating systems. Even many of the people will, like if you are learning something, many people even in the corporate people, they many are worked on this particular Linux. So this is the advantages because it is an independent platform. So that's why I want to elaborate more on this. Embedded Android is also there. Okay, so it's free of use. You can use this particular RTOS things. So this is what an overview of this particular how we use this particular RTOS in our embedded platform or in an IoT platform. Okay, so there are generally three types of real-time operating systems will be there: hard, soft, and firmware. So just a clear differences. Okay, these are some advantages. For time being, I'm not going in deep. Okay, these are some characteristics of that. Okay, so let us see about some popular embedded operating systems which are available in the market. Okay, so one is ECOS, which is nothing but embedded configurable operating systems. Okay, and embed operating system, which is an open source embedded operating systems. Okay, from ARM. And VxWorks, Wind River company introduced this. And one more real-time kernel, OS3 is there, free RTOS operating system. QNX is one more thing. Microcontroller Linux is there. There are some other, you can see some other free operating systems are there. Raspbian, which we generally used in a Raspberry Pi. Okay, there are Skontiki is there, Windows 10 IoT. So these are the few different things are there. So where these generally operate embedded operating systems will use is in car navigation system, parking metric, medical equipments, navigation systems in plane, like IoT devices for smart bulb, car and home climate maintenance device, GPS trackers, aeroplane navigation, solar panels, ATMs are there. So advantages is that it is small in size, faster to load, but low cost, easy to manage, provides better stability, higher reliability is there, provides interconnections will be there. And also there are some other disadvantages are also there, but isn't easy to maintain. Troubleshooting is hard. Okay, limited resources of per memory, and some other this hardware is very limited. Okay, so that's why there are some disadvantages are there. So this is an overview of this particular embedded systems. So let us go and dive into the real things, so what we are going to learn here. So just a second. So fine. So whatever we learned till now, that is fine. If you understood it, it's good. Okay. If you are confused or not understanding, it's okay. Fine. You can refer that. I just give you a brief overview. So let us discuss everything really little related to our hardware sessions or hands-on sessions. Okay. Fine. So we discussed about the building blocks and embedded systems, am I right? So inputs, controllers, and outputs. So IoT system is an extension of this particular embedded systems, am I right? Embedded systems plus cloud is nothing but this IoT systems. Okay, so first of all, let us focus on this particular embedded systems and how it performs, how to collect, what are the inputs, what are the controllers and processor, and later we'll try to discuss about this IoT. So first of all, we'll learn about these embedded systems in deep, so that we'll know how to connect it to the IoT systems. Okay, so fine. So let us discuss here. I mentioned like controllers and processors. Okay, so let us discuss what is this controllers and processors. Can anyone tell me what is the difference between this controller and a processor? Can anyone? You can reply in the chat box. Do you have any idea between a processor and a controller? You can reply in the chat box, guys. Right, controller specific, controller is a system. Right, single unit processor, etc. Right. You have good answers. Thank you for your response. Okay, so let us discuss about this particular processors and a controller. Generally, I'll take you a scenario, okay, for a better understanding. Okay, say suppose if you want to buy a what we say a desktop computer. Okay, so what you do? Generally, can you reply me that I just want to make it an interactive session. So just say suppose if you want to buy a desktop computer, not a computer, just laptop, a desktop computer. So first of all, you need to have a specification. Say suppose all these Photoshop people, gaming people, all they won't use laptops. They generally prefer this particular desktops only, right? Because that will be faster than the laptops. First of all, you need to know the specifications. Okay, so after everything, after collecting what size of monitor you need, what are the CPU you need, what are the processor, what are the hard disk, you'll get everything. I mean, you'll have an idea of all those specifications. Am I right? Right, after that, what do you do after that? Tell me, guys. uh, right, say suppose my intention, I want to continue. Right, after knowing all the things, you'll go to a shop. Okay, right, so like a computer shop, and you'll say that these are my specifications, and please tell me the cost of that. So the depending upon if you are okay with the cost, so what the shopkeeper will do, what the shopkeeper will do. So after getting all these things, he'll take all the things, right? So Intel processor, okay, right, i7, i9, or i5. Okay, so he'll take that particular processor. To that particular processor, he'll try to attach all the other peripherals. Am I right? Yes, your hard disk, your everything, what we say, keyboard, mouse, whatever, what you think, you'll try to attach all those things to that particular processor. Am I right? So that is what the processor is all about. So we have a CPU. To that this particular CPU, we try to attach all the other peripherals. That RAM, ROM, input output ports, timer, serial ports, X, Y, Z. So all these chips will be attached externally to that particular CPU, to that particular motherboard, to that particular processor. Then we call that as a processor. But if you don't want that and everything is mounted on a single chip, say suppose the CPU or the RAM, the ROM, all these things are mounted on a single chip, then we call that as a controller. Got it, guys? So processor is nothing but to that particular CPU or to that particular processor. If we connect all the things externally, then we call that as a processor. And if all the things are on the same thing, then we call that as a controller. Okay. So here, let us see the differences between. I hope you understood about the difference. What is a processor and a controller? The differences between a processor and a controller is the processor is can be understood as a heart of an computer system, and this controller will like understood as a heart of an embedded systems. Okay, so why it will say is, for a say suppose for your computer, if your speed is not good, if you want to upgrade your RAM, you can upgrade it. But coming to this particular controller, you can't upgrade your RAM. Why? Because everything is mounted on a single chip. There is can't say suppose your mobile phone, so everything is mounted on that particular single chip. Okay, but you can't take it or you can't replace it with some other RAM or the ROM. Am I right? So that's why this controller, we call that as an embedded system, heart of an embedded system. Okay, this processor is an electronic component which acts as a processing device, and this controller will be acting as a controlling device. Okay, and the processor is a processor where the memory and the IO components are connected externally, but In controller, everything is present on that particular chip, right? So everything is connected internally, right? So and here the circuit is complex because of that particular external connection, but here everything is on the single chip, right? So present there is no need of all the stars. Okay. So these are the different types of microprocessors. So complex instruction set microprocessors are there. Application specific integrated circuits are there. Reduced instruction set microcontrollers. Digital signal processors are there. Coming to this controller, it all depends upon the bit architectures. Okay. Just a second, guys. Right. So these are some other applications of a processor and a controller. Calculators, gaming machines, mobile phones, all this comes under the controllers and the processors. Okay, right? So let me show you some which devices which are available in our market for all applications. It doesn't mean for only one specific application. So it all depends upon multiple applications. Okay, so here there are some controllers are there 8266 and 832, 8285. So and some are Arduino families. So these are the few popular STM32 series Texas Instruments. These are the popular. Particle is also a little popular. 8 Mega 328 Etni. These are some popular microcontrollers for our general use of developing the products. Okay, the a part of that they have some other controllers are also there. NXP, LPC series, microchip, PIC series. Okay, Silicon Labs, TI lab things. Okay. So coming to the processors, we have Raspberry Pi family, is there BeagleBone Back family, Intel Edison. So a part of all this, the top ones are popular, and the remaining are also there. So expressive things are there. Qualcomm, Samsung, Microchip, Rockchip. These are the different processor. Jetson Nano. So AI integrated this one, Jetson Nano. This is are the some processors are available. Apart of that, there are some other things are there, like specialized for IoT platforms. So Amazon free RTOs will be there. Google Cloud IoT Core are there. Nordic Semiconductor NRF series will be there. So there are two low pan wide devices will be there. Sigfox NB IoT modules are there. So industry graded controllers are also available. Like these controllers, I told you, right? These are for use generally used for industries. Okay, Siemens Simatic IoT 2000 designed for industry IoT applications. So Advanced Tech Wise 4000 series, Beckhoff CX series, Wago PFC 200, Sennheiser Electric Modern. These are few other industry graded controllers, and there are some gateways and edge computing devices are also available. Nextcom, Y, Edgex, Foundry, SmartThings Hub. Okay, Cisco from Cisco company. Some devices are available, and wireless and communication modules are also there. Okay, it doesn't mean that you need to use all these for your projects. No, I'm not in. I'm just giving an overview of what are the different devices or modules are available in the market for different applications. For a company, if you're going for, they'll follow some modules. Say they follow like dual more this Nina W10 for their applications. Okay, so Zigbee 3 will be there. Some will follow Nordic Semiconductor. So for their application, that module is good. So they use that particular module. Okay, so AI optimized and vision processing chips are also there. Okay, and low pan and specialized IoT modules are also available. Okay, so I'll just introduce to few modules. Okay, So the basic one which is introduced by Intel is nothing but 8051. If you are from AC background, you'll know about this particular AC 8051 controller. Okay. And at that particular time, we have couple of other things: 8051, 8052, 8031, etc. All right. So currently, for a student point of view, Raspberry Pi, Arduino, and Node MCU products are a little bit popular. Okay, they you can use them. Both are like all are like budget friendly modules. Okay, so we'll discuss about this Raspberry Pi at the end. This is also acts as a mini computer. So this is the basic Raspberry Pi. So this is Pi 3 model and this is Pi 4 model. Recently, Pi 5 is also released by this Pi Foundation. So there's an example like Oracle's developed it as a supercomputer with 1,000 plus Raspberry Pis. So there are some Arduino boards are there. 16 different Arduino boards are available. Okay, some of them are popular, some are not. But for your applications, these Arduino boards can also be used. Okay, and 10C boards are available. Okay, and Node MCU, that is what I'm explaining you, or that ESP8266 or ESP32 boards are available. We'll discuss that. And Beaglebone Black, this is just like your Raspberry Pi. You can also use this particular Beaglebone Black for your applications. Okay, and a part of that popular boards, there are some other boards are there like Intel Edison, which is like an Arduino expansion board. And from Texas Instrument, we have a Launchpad. Okay, ARM Cortex A9 MM4 is there, and Asus Tinker board is available. Okay, this is also a processor. From Samsung, we have the Android XU4 board. Intel NUC, next unit of computing. So this is also a powerful board of gaming, and Jetson Nano is available. I told you, right, this is board is used to, I mean, for AI purpose. Okay. Jetson TX2. This is a world leading AI computing platform. Okay, there are Jetson TX2 boards are there. Jetson AGX Xavier is there. Low Pi. This is also just like your Pi model. So LoRa module, very small inside, and this is an Indus board coin, which is very small inside, just like your coin. Okay, this is a particle boron. STM32 nuclear board is there. Okay, there is a good board. You can also use this board, and all these boards will be used in different applications. Right. So these are the different things which are boards are available in our market. Okay. So right now, so I'll try to introduce a board for a friendly board or a budget friendly. You can develop your projects in this particular boards. Okay. So for that, let me introduce the board, which is a popular board, which is nothing but Arduino. So, do you know about this particular Arduino? Have you worked on this particular Arduino before? Have you learned about this Arduino before? You can pin me in the chat box. Let me see how many of you know about this. You can give some are saying no, little bit, yes. All right. No, yes, no ideas, sir. We developed a robot. We developed a RFID. You know boards. Yes, yes. Fine. So let me introduce it again. Okay, if you are not didn't know about this particular board. Okay, so let me introduce it, and we'll try to do some hardware sessions also on this particular hands-on session on this Arduino also for a better understanding. Okay. Okay, for people who don't know these boards, they can also work on this. People who already know, try to learn it, and because maybe some things which you don't know will be discussed. Okay, all right. So right. So people who know about this particular Arduino, can anyone tell me what is this? I mean, is it a controller or it is a processor? Controller, processor, processor, controller or a processor? Controller. Have a controller. Both. Okay. Okay, fine. So let me explain you. Okay. So technically speaking, so these are my what do we say, things which we are going to discuss. I'll give you an overview of Arduino, and we'll discuss about Arduino Uno, the basic board, and also we'll discuss that controller called Mega 328P, and we also will discuss how to install this particular IDE. Okay, right, fine. So let's overview. Technically speaking, this board, we won't call it as a controller or it is not a processor. We call it as a development board. It is not a controller, it's not a processor. Okay, we call that is a development board. It is a circuit board. Okay, where a microcontroller will be there, and there are some other stuff is there which is mounted on that particular to that particular microcontroller. Okay, so that's why we call it is as a development board, not a controller. If you say that it is a controller, you need to have only the IC, because IC is a controller. Okay. So because why we people are using this particular development board is, so if you want to write any code on any controller, so you have only the IC. So to write a code on this particular IC, you need some other what we say boards. Okay, where you need to place that particular IC on the board. You need to write a code, and this particular IC only understands this machine learning language. Okay, I don't understand that what we say C or Python or C++. So what we need to do, we need to convert that. Am I right? So for converting, we need some other softwares, and again after converting that, again we need to dump that into that particular IC. Okay, for dumping that, we need separate boards, some separate softwares. Okay, so if suppose there is any changes we need to be done in that particular code, again you need to follow all this stuff, write it, convert that into hex file or machine and other files, and then you need to dump that using that particular boards. Okay, this is a huge process. So to avoid all these things, what the few companies are doing this, they develop their development boards. Okay, using that particular development boards, we can just plug and play that particular microcontroller. So just connect that board to your system and write the code, and with a single button, the code will be dumped into that particular IC, and you can do all those changes. Okay, so that's why we call that as a development boards. So this particular Arduino will use as a series of controllers, microcontrollers, which are called Atmega AVRs. Okay, so these controllers are made by a company called Atmel. Okay, so right, so here this Arduino, generally what we generally have this, these are a few other data is there. Let me avoid that. So these particular Arduino which are available in our things are all are clones. Why? Because this particular Arduino company made their products and softwares as an open source. Okay, complete open source. Open source, you know about it, open source, right? So all the devices which we have available in our market all are the clones, because as it is an open source, the hardware is also open source. There are some other vendors, third party vendors developed that with the same functionality, with the same uses. They developed it some what we say boards. We call it as a clone boards. Okay, so these clone boards, the cost when I compare with the cost, the clone boards cost very less, like 300 or 400 like that. But coming to the original ones, you'll come across 2000 or 3000. So in generally, most of the people will use only the clone boards. Okay, suppose if you damage that particular clone board, no need to worry, because you have that is a cost very less, right? Like 300, 400, you can buy a new one and you can use in our application. The functionality will be the same. There is no what we say alterations are there. There is no uh, what we say faults will be there in that particular clones. So the original works with same thing, and the clones also work with the same functionalities. Okay, so the key features of these particular Arduino boards are like so we can able to read this analog and digital input signals from digital things. We can integrate sensors, we can integrate actuators, we can control the analog separately, we can control digital pins separately, etc., etc. Right, and these can what we say boards can be functioned using some instructions. Okay, right, but some instructions where we having a software which is nothing but Arduino IDE. So integrated development environment, using that particular IDE we are going to upload the code. So previously most of the programmable circuit, I told you, right, there will be an extra hardware we need to have to dump that code. So to avoid all these things, we have this particular IDE which is very simple. We can directly dump the board code using a USB cable. We can connect it just like a plug and play options. Okay. So here this IDE is uses a simplified C++ version, which is easier to learn the programming part. Okay. And these are the different flavors of Arduinos are available, out of which only few got very famous. Okay. And let us see what are those boards. Okay. I'll give you only the popular ones, which is the first one is that Arduino Uno R3. R3 is nothing but the revision 3 version. Okay, and this have microcontrollers. Different flavors have different flavors are nothing but the types of Arduinos. So all these types of boards having different microcontrollers. Okay, so this board having one microcontroller. If you go for another board, there are some other controllers are there. So LilyPad, this is a wearable e-textile. We use this a wearable is a wearable e-textile technology. It is a washable board, which we use in textile industries. Red board, because that what we say, and red board almost the same, but there is some differences are there. Mega is there. So, nothing but this is we call that is as a Uno's big brother. Okay, because the inputs GPIOs, general purpose input output pins, are more when compared with the Arduino, except that everything is the same. Okay, Linando is one board. Okay, there are some other flavors are there. Dion, Yan, okay, Micro, Explorer, Mini. These are the few other boards. You can see that Explorer, it is looks like a joystick, right? You can also develop some project using this particular Explorer. You can like drones, robots, etc., etc. You can develop with this particular Explorer. Okay, so there are we can integrate all types of sensors. Okay, all sensors will be compatible to this particular Arduinos. Okay, and also there are some shields are available. Okay, shields are nothing but to add some additional capabilities or features to that particular board. So if you see all the we already seen that particular some few boards, right? So if you want to integrate a screen to that LCD screen to that particular board, so we need to use of this particular shield. So if you want to use some other purpose, like if you want to attach some Ethernet, so we need to purchase this particular shield for that particular Ethernet, and we need to for Ethernet, and we need to interface that to your Arduino. So there are some shields are available depending upon our specifications. We have these particular shields. Okay, um, right, and both types are there. So let me show you what are the boards, what are the different microcontrollers are used, what are the different inputs and outputs are there, what are the operating voltage. I'll just give you an overview of all these board types. Okay, so these boards which I'm showing you here are using a microcontroller called Atmega 328. Okay, so this particular Atmega 328 will have a 5 boards. This microcontroller is used by these boards like Redboard Pro, Mini. So these boards are using this particular Atmega 328, and also there are few other boards are there. from Ethernet, FIO, LiniPad, main board. So the operating voltage will be 5 volts for most of the cases, and 16 megahertz. The digital pins will be the same, 6 analog and 14 digital pins. Okay, and there are some other boards with the different microcontrollers like Atmega 328U4 microcontroller. So this microcontroller will be used by these boards like our Linando Pro Micro, okay, Linipad or USB. This having again digital pins will be 26. There will be slight changes in that, and also some board controllers are boards are there which are using Atmega 2560. So this microcontroller will be used by these things. So almost all are same. The programming will be the same, but there is a slight difference between the operating voltage, clock speeds, and digital IOs or analog IOs, general purpose input outputs. Okay, so these are few other boards. Okay, so this is a latest board which is introduced by this particular Arduino board, which is nothing which is nothing but R4 version. We call it as the revision 4 version. So which is having a more features when compared with R3. Okay, so there is an LED matrix will be there. So this particular this is a minima, and this is R4 Wi-Fi. So the name is little different, guys. Pardon, sorry for that. So they have inbuilt Wi-Fi, Bluetooth capabilities are there for this particular uh, ports. Okay, so I told you, right, there are some advanced versions are there. So it supports battery powered are there. We can directly integrate with it. Arduino cloud compatibility will be there. You can diagnose some runtime errors. Okay, and there are some matrix board is also available for this R4 version, 12 by 480. So you can display some letters on this particular board. You can display some what we say words or message on this particular LED matrix. Okay, the more memory and faster clock will be there. Okay, new board can be interface on this particular boards. Okay, USB-C connector is there. So normal USB R3 version will have some other connectivity, but here for this we have USB-C connector is there. Okay, Wi-Fi and Bluetooth capabilities are there. Large voltage ranges are there for this particular R3. And also some other boards are also available. These boards are what we say introduced recently. Arduino Giga R1 Wi-Fi board, just like your Mega board. This is an extension of Mega. We call it as a Giga R1. This is a revision one. So there were a 4G GNS module, global module, module global. This is one more board. And Nano 33. Generally, we have Arduino Nano board. So this is a advanced version of that 33 BLE Bluetooth version, which is revision 2 or revision 2 module. Okay, so these are the boards which are recently introduced. If you have any queries till now, you can ask me, guys. Okay, right, fine. So let us move further. I'll just give an overview of this particular Arduino Uno. This is a basic board, right? So in tomorrow's session, we'll try to do some directly on hands-on on this particular Arduino. Okay, so this is the Arduino board, Arduino Uno. So this particular Arduino Uno is available in two flavors. One is a dip flavor and another one is SMD flavor. You can carefully observe this is a dip flavor and is an SMD flavor. Both are having the same things, but only the difference is the microcontroller. So in dip flavor, you can see the microcontroller is just like an IC. Okay, and SMD flavor, it is mounted permanently on that particular board. So can you anyone tell me which one is preferred, dip flavor or SMD flavor? You can ask, tell me in the chat box which flavor is suitable, dip, SMD. You can give your answers in the chat box. Okay, right. So let me explain you. Dip flavor, we use a dip flavor. So why we use dip flavor is, say suppose if you are working on this particular SMD flavors, okay, so you mounted some sensors, you connected everything due to some XYZ reasons, so there is some shortage, okay, your IC, this microcontroller got shorted, so you got burnt, so this what we say, controller got damaged, okay, so what you have to do, so you can't replace this particular controller, but in SMD flavor you can replace it, because you can see this is an IC. If something happens, you can take this particular IC out and you can replace it with a new one. Or else, if the new one is not available, you can take it out. You can use some other peripherals also for other purpose. Okay, so like that we can use this dip flavor. So as a dip flavor is more suited, okay, uh, based on, I mean, compared with this SMD flavor. So for all the instance, we'll use a dip flavor. Okay. So let me give an overview or of this particular Arduino. What are the different things? This is the hardware overview. So I'll give you the software overview later. Okay. First thing is we have an USB plug. Okay. So this USB plug is nothing but we have a cable. Okay. That we can connect this particular Arduino, you know, to our laptop, to our system using that particular cable, where this particular cable is connected to this particular USB plug. Okay. So using this particular USB plug, the data will be transferred from the IDE or the software part program to this particular board. Okay. And here we have an external power supply. So here you should not use both these USB plugs and power supply simultaneously. So thing is, say suppose if you want to charge your mobile, there are two ways are there. One is you have a USB cable. So one is you use your adapter, charger adapter, and you can directly plug into your socket, electric socket, and your mobile will be charged. So if you don't have a adapter, what you do, you'll take that particular pin out, I mean adapter out, adapt, you don't have an adapter, you'll have a cable, so you'll directly connect to that particular cable to the laptop. Okay, right. So whenever you connect that particular cable to your laptop, the charging will be done, at the same time data will be transferred. Okay. Yes or no? So using this particular USB cable, whenever you're using USB cable, data will be transferred, at the same time power is also there. And we have an external power supply. Say suppose if you dumped your code into this particular IDE, and there is no need of connecting it to your laptop. Okay, once it is deployed, and you can take it, and if you build that particular product, you need to give a power supply, right? So using this particular power supply, there is an adapter will be there. Using that particular adapter, we can give the power supply to this particular Arduino. So that is what the usage of this particular power supply. And we have a power pins are there over here, and also general purpose pins are there, like general purpose input output pins. Okay, GPIOs we call them as. So for this particular Arduino, we have two different types of GPIO pins are available. One is analog pins, another one is digital pins. Okay, so totally we have 6 analog pins are available, and 14 digital pins are available at this particular point. You can see here digital and analog. Okay, fine. And here this is our microcontroller. This microcontroller for this is Atmega 328. And we have a reset button and a in circuit serial programming part. And here we have a digital pins are there. Okay, one ground pin is available. Here if you want to transfer the data using serial communication. So TX and RX pins are available. We'll discuss that little later. So we have that particular serial communication pins are also available over here. Okay, so this is an overview and this is a in detailed version. So some pins will work like there are multiple functionalities for that particular pin. So a part of that general purpose pin we can use for other purpose also. Okay, so let us go dive into this. This is a pin layout of this particular, what we say, Atmega 328, and this is a pin layout of Arduino board. Okay, the same thing will be mounted over here. Okay, fine. And here let us go in deep and learn about this particular microcontroller. So here the microcontroller which is mounted on this particular board is Atmega 328. Okay. So let us see the specifications. So this is Atmega 328, which is from Atmel company. It follows 8-bit AVR architecture, automatic voltage regulator. Okay, so this is a 28-pin IC which works with a 5 volts DC power supply, and we have 14 digital input output pins are there, and 6 analog input output pins are there. We have an ROM size of 32 KB and a RAM size of 2 KB, and we have an EEPROM which is nothing but 1 KB. We have a clock speed of 16 megahertz. We know about ROM. We know about RAM. What is this EEPROM? Can anyone tell me in the chat box what is this EEPROM? And what is the use of this particular EEPROM? Electrically erasable programmable ROM. Yes. What is the use of this particular EEPROM? Why we have this particular EEPROM? What is the use of it? Can anyone thinks? Yes, someone is real-time programming. Okay. Okay. In general, what it mean is retains data when power switches off. Okay. The thing is, main intention is electrically erasable programmable read-only memory, right? So what says suppose your wrote a program, okay? So that program after doing that is working fine. Now you want to replace that with some other program. So this EEPROM will help you to erase that particular program in that particular memory and with a new one. So EEPROM will help you in that particular platform. Okay. So for that we use this particular EEPROM is there, and the clock speed is there. What is meant by clock speed? Can someone tell me what is meant by a clock speed? Clock speed. What is the use of this particular clock speed? Operation of the board. Okay. Rate of speed CPU executes instructions. Yes, perfect. And clock cycles to all the modules. Yes, yes, almost all are right. You know about this because you are in this generation. You know about this particular clock speeds. Right. So these are the specifications of this particular 8 mega. P stands for picofarad. Okay. Right. And this is the pin layout, which I already showed you. So here to this particular controller, there is a resonator is available. Okay, this is a resonator which is available. This is connected to the microcontroller is a crystal resonator which controls how fast the microcontroller is running. So this crystal resonator will help you the controller to how controls how fast the microcontroller is running. Okay, and we have a crystal oscillator will be there, which is nothing but which gives you this particular what we say clocks. Okay, and we have one more controller is available on this particular board. Okay, which is nothing but Atmega 16U2. Okay, so this is the main IC, okay, of this particular Arduino board. So what is this controller will do is, so in this particular Arduino, you know, there are two controllers. One is an Atmega 328 and another one is Atmega 16U2. So this 16U2 is used to upload the code to the main microcontroller. Okay. So which is nothing but Atmega 328. So this microcontroller helps to get the data from that particular laptop and pushes the data to that what we say Atmega 328. So this microcontroller helps in order to upload the software which you created for the main microcontroller. Okay, fine. And this particular chip we are using that USB B cable to that to communicate that. So once the program is running, this chip is allows you to send the messages back and forth between the computer and Arduino, and this is important for debugging extremely. Okay, one great thing is that we can use this USB port for the power. Okay, that's what I already explained. And we have a voltage regulator is there, because this operating voltage of this particular Arduino, is 5 volts. So generally we won't get 5 volts adapters. So this voltage regulator will convert that particular 9 volts or 12 volts adapter, that power supply, into a desirable 5 volts supply. So this voltage regulator will be there, right? A 7805 board regulator will be used at this particular point. Okay, and we have a reset button is available. So this way, whenever we press this particular reset, the program will reboot in the sense, again it will restart. Okay, and we have a pin connectors are there. You can see these are the pin connectors. So if you want to connect to some, okay, sensor. So for a sensor, we need to give some power supply, right? So we can get extracted power from this particular power pin connectors, like 5 volts or 3 volts, and ground pins are also there. Using that, we extract the power and will give it to the sensors or actuators. Okay, and also there are TX and RX pin is available for the serial communications, UART serial communications. This is available in digital pins 0 and 1. So say suppose if you want to connect any Bluetooth, Zigbee or GPS, so this TX and RX modules are pins are used for that serial communications. Okay, and we have totally of 14 digital pins are there. Right, the difference between an analog and a digital. So analog pins are nothing but it will give you some values like voltages things, and analog digitals are nothing but we have a binary data like zeros and ones. Okay, so 0 is nothing but 0 volts, 1 is nothing but 5 volts. Okay, and we have an analog reference pins is also available, and there are some other extra features are there, like PWM pins are there, pulse width modulation pins are available. Whenever we are working on this particular PWM pins, I'll try to give you more details of this. So totally we have 6 PWM pins are available. Okay, the negation marks, if you see, right, some negation marks are there. So those pins are PWM pins. Okay, and we have totally of 6 analog pins are there. Okay, A0 to A5, and also we have some extra functions are also there for that pins. Okay, and okay, some extra functionalities are like serial clock, MOSI, MISO, like I square C, SPI protocols. So for that, yes, if you are right now, it is not I square, not important for you. Okay, for this point of time, if you want to know, you can work more on that. Okay, you can go through them online. You'll get all those details. Okay, these are the technical specifications, like controller overall specifications. Like Mega 328 works with 5 volts, GPIO are totally 20, 14 digital, and 6 analog. And there are some SRAM, EEPROM, clock speed is also available. Okay, this is the overall things of this hardware. Okay, so let me end till here. So in tomorrow session, we'll discuss about the software. So till now, if you have any queries, you can ask me in the chat box. So will the 6 analog pins gives the same outputs? Yes, 6 analog pins will give you the same thing. So all are same, acts as the same things. Okay, if you have any queries in today's session, you can ask me, guys, or regarding this Arduino, also you can ask me. So I'll try to uh, answer you. You have some time, so you can answer for it. So it is not, we can't say that it is an outdated things. Okay, so say suppose if you are working on a smaller applications, So this particular Arduino Uno is the best one. Okay, the controller gives you the best outputs. Okay, so for a smaller applications, we use this particular Arduino. Okay, so it is not like outdated. So this particular Arduino, we use it for, say, suppose if you want, if you are working on some, say, suppose, what example, like you want to know the temperature of a particular room. Okay, just a small room. Okay, or else a small motor. You have a motors, right? So this particular motor, if you want to know the temperature, whether it is heating up, for that, or some temperature sensors for in agriculture sector, or something, like if you want to run a, what we say, robot, small field robot. For that, for all these applications, this Arduino, is a good one. Okay. Okay. If you want to control it to an IoT applications to want to push the data, then Arduino won't be a better option. So we'll discuss that in the next classes. For a smaller applications, this Arduino is the best. Okay. So we can connect sensors, but we need to think about the sensors. What we say, data. I mean, not data, like capability of that particular sensors. If it is a normal sensor, then it is okay, fine. If you are using a high-end sensors, the Arduino may withstand or may not withstand. Okay. So you can connect, say suppose as normal sensors will be there, like IR sensors. Okay. You can connect up to 4 to 5 sensors. Okay. If you have like temperature sensors, you can connect one or two. Okay. If you have LEDs, like output devices, you can connect up to 10, 20, like that also. Okay. So we need to check whenever we are developing this Arduino, we need to know the full capability of that particular Arduino, whether we can use these many sensors or that, then we can use. I told you, right? It depends upon the sensors. Any other things are there, guys, which you want to clear? I didn't get you, Dakshinamurti Garu. Sensor, IoT, hub, 3G to cloud. So all the Arduino boards are having the same capabilities, guys. Only the programming is the same. Okay. There are some have limited uh, data pins, digital pins. Some have more pins. Except all the programming part are the same. If you know one board, you can explore. I mean, you can work on all other boards also. Almost all are the same. There is no confusion. Just you need to uh, know about what are the inputs and outputs, how many inputs are there, how many outputs are there. I mean, sorry, how many GPIO pins are available. Okay, just like that, you need to connect. We can't connect mobile to Arduino Unos, guys. Okay, for that, we need to have some external uh, components we need to attach, and then we need to. Any other things? IR sensor is nothing but infrared sensor. So we'll discuss that later. Okay, just to identify any object is there. With that, we can identify. Okay, right then. So thank you, guys. Thank you for attending. See you tomorrow. And tomorrow session we'll try to work on this particular Arduino, and we'll work what is how to program it. That we'll discuss in tomorrow sessions. So thank you, guys. Thank you for attending. See you tomorrow.